In the previous few sections, we've talked about how some practical considerations, enforced by natural selection in the case of brains, force the existence of a modular hierarchy of condition detection. And we identified this list of specific properties of modules. Then we went on to note that changes to conditions and receptive fields have to be very carefully managed and limited, and generally the only safe changes are slight expansions to receptive fields that are already close to being detected. And that means that generally, even after a change, a receptive field will still be detected in almost any exact repetition of circumstances in which it was detected in the past. So receptive fields are fairly stable. So let's move on to a very critical implication of this relative stability. Receptive field definitions can only change relatively slightly over time. And receptive fields have recommendation strengths that in combination determine behavior. So given these limitations, remember that the behavior recommendation strengths are accessed by detection of the receptive fields within sensory inputs. And these sensory inputs are derived from the external environment. But what if the most appropriate behaviors aren't being adequately recommended by these directly detected receptive fields? For example, human beings can plan for situations that bear minimal resemblance to their current sensory environment. How can the receptive fields relevant for future planning be activated if they're not there in the sensory inputs? And on what basis could inactive receptive fields be identified as possibly relevant? Remember, the resources in a complex learning system don't have labels indicating their cognitive roles. So the system can't just activate all the cognitively related modules. It's got no information it could use to identify those kinds of cognitive connections. But one thing a learning system could do is record information about past simultaneous activity of different groups of receptive fields. Then, if a receptive field isn't being detected, but it was detected in the past at the same time as some currently detected receptive fields, there could be a good chance that the inactive receptive field has some relevant recommendation strengths. For example, suppose some group of columns was detecting their receptive fields, and a short while later, some but not all of those columns again detected their receptive fields. There's a reasonable chance that the receptive field in the group, that earlier group, that's currently undetected may have some relevant recommendation strengths. It would be useful if the active members of the group could indirectly activate the inactive members on the basis of that temporally correlated past activity. To give another example, suppose some group of columns are detecting their receptive fields in response to some situation. In some later situation, a different group of columns are active, in other situations yet other groups, and so on. On a number of occasions, a different group of columns was active, but suppose also that this column has tended to be active on most but not all of the occasions, and this column has also been active on many of the same occasions, and this one, and this one, and this one. So there's a group of columns indicated by the green arrows at the top that's tended to be active at the same time on a number of past occasions. Lots of other columns have also been active, but not with the same consistency. Now, suppose that later some, but not all of this group, happen to be active again. Given the consistency of past simultaneous activity of the members of the group, it's plausible that the inactive member of the group may have some relevant recommendation strengths for the current situation. And it should therefore be indirectly activated on the basis of frequent past simultaneous activity. Now let's think about a third possibility. Columns may expand their receptive fields simultaneously. Suppose that in some novel situation, this group of columns all change at the same time. And suppose that in some later situation, some of those columns happen to be activated again. Once again, perhaps the columns in that original group that are not currently active may still have some relevant recommendation strengths, and indirect activation of those columns would be behaviorally useful. So we've identified 3 different types of information that could be available to access recommendation strengths that aren't present directly in current sensory inputs. Indirect activation of receptive fields on the basis of recent activity at the same time as currently active fields. Indirect activation on the basis of frequent past simultaneous activity. And indirect activation on the basis of past simultaneous change. On the other hand, if any or all of these indirect activations took place in an uncontrolled fashion, the result would be confusion and a meaningless pattern of activation. So indirect activations must be behaviors that are recommended by receptive field detections and accepted or rejected just like any other behaviors. And there's another important point. Indirectly activated receptive fields could themselves recommend indirect activation of yet other receptive fields. So you could get long sequences of indirect activation, which again could be behaviorally useful, but more and more remote from the current sensory environment. And yet another important point. Past activity just before or just after could also be a useful indicator. For example, suppose we're looking at columns that expanded their receptive fields at 2 consecutive points in time. Then, as before, later a subset of the group at the first point in time becomes active. That group indirectly activates the complete first set. There then could be behavioral value in that first set, recommending activation of the set active at a slightly later point in time, on the basis of receptive field expansion just a bit later. Now, all these indirect activation mechanisms only use information that could plausibly be available to a complex learning system, but they vastly expand the range of information that could be available to guide current behavior, and they expand that range on the basis of past temporal correlations in activity. And sequences of indirect activations of different types could provide different routes to access the recommendations needed. So we've identified a range of possible situations in which indirect activation of a module might be behaviorally useful, even if its receptive field isn't there in current sensory inputs. And we've concluded that these indirect activations are themselves behaviors that have to be carefully managed.